Welcome to this session on using Retrieval Augmented Generation, or RAG, from your database to gain insights into the R Consortium. I'm Mark Hornick, joined by Sherry LaMonica with Machine Learning and AI Product Management at Oracle. Now, the R Consortium blogs are a valuable authoritative resource filled with R community-related insights. The URL is shown in the upper right. Now, in this session, we'll demonstrate how to leverage this material with generative AI, specifically using Retrieval Augmented Generation to obtain richer, more current responses about the R Consortium and the broader R community. But why RAG? Most large language models, LLMs, have fixed knowledge up to their training cutoff date and might miss the latest events or resources. RAG addresses this by combining generative AI with vector-based semantic similarity search, allowing us to retrieve and synthesize information directly from up-to-date sources, resulting in more accurate and timely answers. For example, we may want to learn details about recent events, such as this new R+AI conference we're part of today, which typical LLMs won't know about yet. Or we want to explore current learning resources or educational initiatives spearheaded by the R Consortium. Now, as we've discussed, RAG combines two key strengths: retrieval-based AI, which uses vector-based semantic similarity search to find relevant information, and generative AI, where LLMs create context-aware responses. The central idea is to provide the LLM with new trusted knowledge without the need for costly fine-tuning. And there are clear advantages to using RAG, including greater accuracy, efficiency, transparency, and improved security, among others. But let's take a high-level look at the RAG process. First, information relevant to the user's prompt is retrieved from a vector database. Then, the user's prompt is augmented with these relevant document chunks. And finally, this augmented prompt is sent to the LLM, which generates a response that incorporates the up-to-date retrieved content. At a more granular level, the typical RAG pipeline starts with data sources that are loaded into a repository, such as cloud storage. From there, the documents are broken into smaller chunks, perhaps using a sliding window technique, though several chunking strategies exist. Now, each text chunk is transformed into a vector. A vector is a high-dimensional numeric representation that captures the semantic meaning of the text. Each vector is then stored in a vector database, and a vector index is created to accelerate searches. Next, when the user submits a prompt, it too is converted into a vector using the same transformer model. The system quickly compares this query vector to those in the vector database. With millions or even billions of vectors, a naive search would be computationally expensive, so advanced indexing techniques are applied to enable fast, accurate retrieval. Now, with RAG, we use this process to identify the top matching document chunks based on semantic similarity to the user's prompt. And these selected chunks, along with the prompt, are then combined and sent to the LLM, which generates a response that incorporates the retrieved up-to-date information. Of course, when new information becomes available, the vector database should be updated to ensure the latest knowledge is included in future responses. Now, Select AI automates this RAG process, reducing it to two simple steps. You create what we refer to as an AI profile, and then create a vector index. At that point, you can start asking questions. But what is an AI profile? Well, an AI profile supporting RAG is a configuration object that defines which AI provider and specific models, both the LLM and the transformer, that Select AI will use. Now, while an AI profile is essential for RAG, it also supports other AI capabilities, and I'll touch on that later in the session. As you see on the right, an AI profile is composed of several attributes. It includes the profile name, the AI provider, such as OCI, OpenAI, Google, or others. And next, you provide your credentials for the selected AI provider, enabling secure access to their API. The specified vector index supports the semantic similarity search. Following this, you specify your preferred LLM, the transformer or embedding model, and a few other settings. For example, you can enable or disable sources, allowing users to see exactly which document chunks contributed to a particular response. So what's a vector index? Well, a vector index organizes and stores vectors, making it possible to efficiently search for semantically related information, essential for RAG workflows. In our setup, both the vectors and the vector index are natively managed within the database. To configure a vector index, you provide a name for the index, the AI profile, which specifies the transformer to use, the vector database provider, in this case, Oracle, since we're using the database directly, the location of the documents you want to vectorize and index, and your object storage credentials, giving access to the source documents in object storage. As new documents are added to your cloud storage, they're automatically vectorized and incorporated into the vector index based on the refresh rate that you define. For our demonstration architecture, before I hand it off to Sherry, we're using Oracle Autonomous AI Database with SelectAI. Autonomous AI Database is a cloud-based, fully managed database service that automates many complex management tasks and comes with advanced built-in AI capabilities like SelectAI. SelectAI is offered as a core database feature, implemented through the PL/SQL package called DBMS Cloud AI. However, as R users, we often prefer working directly in R. And for this demonstration, we've developed a sample R code wrapper to access RAG-related functionality from R. With SelectAI, you can choose your AI provider, as well as the specific LLM and transformer you want to use. Now, these AI models are available from a variety of providers. You can even provision a private endpoint in Oracle Cloud Infrastructure if you want to ensure your data stays private and doesn't reach an external LLM provider. In this demo, we'll use the OCI GenAI service. Our documents, the R Consortium blogs, are stored in cloud storage. For this demo, we're using Oracle Object Storage, although other storage options are also supported. Now, SelectAI automatically generates the vector index and manages the entire RAG process for you. It's worth noting that, for demonstration purposes, our R wrapper doesn't map one-to-one to every function in the DBMS Cloud AI package. You can find more details in the resources we'll share at the end of this session. Sherry, let's see the demo.
Thank you, Mark. I've sourced my helper functions. Now let's see how we connect to the database and set up our environment. I'm using the R Oracle package to establish a connection to our Oracle Autonomous AI Database instance. The connection is successful. Now we have access to the SelectAI functionality from our R session. Let's create our AI profile, which specifies our LLM and vector index, along with LLM-specific settings. And this profile specifies our OCI credentials, the model parameters, and the name of our vector index. We just created our AI profile named OCI for RCB. Now let me show you the R Consortium blog and article files we'll be indexing. These are stored in a bucket in object storage. And you can see here we have multiple blog posts and articles. Now I'll create the vector index. SelectAI will automatically chunk these documents, generate embeddings, and store and index them for semantic search. We've started our vector index creation process, and the refresh rate will determine how frequently we want to check for new content in our bucket. And then SelectAI will automatically chunk, vectorize, and index the new content. Let's check the status, first creating a vector index status view, and then checking the status of the vector index creation. You can see the job is in progress. Let's wait for this to complete. It is completed, and our index is ready to use. Now we can start querying. Now let's see the difference between asking the LLM directly versus using RAG. I'll ask about the R and AI 2025 conference an event that wouldn't be in the LLM's training data due to the cutoff date. So let's try direct chat with the LLM. Notice that the LLM responds that it doesn't know about the conference, but offers guidance for finding out more. The LLM doesn't have specific information about this conference because it wasn't in its training data. Now let's use RAG with the same prompt to have the LLM generate a textual response. With RAG, we get specific, accurate information about the R+AI 2025 conference drawn directly from the R Consortium blogs and articles that we index. In the RAG response, we see the source documents and their offsets, which show where the retrieved text begins and ends within each document. By augmenting the prompt with our document content, the LLM can provide more relevant responses based on our private data. If we want to see the specific chunks of text from our documents provided to the LLM, we can use show chunks. Here you can see the document chunks that were retrieved through semantic similarity search. These chunks are what get added to the prompt before it goes to the LLM, which can reduce hallucinations. The LLM responds using data in our object store, not just the knowledge it gained from its training data. Now let's try a more complex query that requires synthesizing information across multiple documents. Using RAG, Select AI identified relevant chunks about user groups, community engagement, and learning resources, and the LLM organized them into a coherent 5-step learning plan. Let's ask about the educational resources available through the R Consortium. Again, we get specific information about R Consortium programs and resources, and this would be valuable for building a chatbot or knowledge-based application. One powerful feature is maintaining conversational context across calls to your LLM. Here, I'll create a conversation, ask a question, and then ask a follow-up question that relies on context from the first. What does the R Consortium do to support the art community? Next, we ask the follow-up question without repeating the context. What specific programs do they offer for funding? This conversational context is key for building natural chatbot experiences. And in the response, we see both the sources and the offsets. Finally, I'll demonstrate multilingual RAG queries using in-database transformers. First, let's see what transformer models are available in my database. We're going to use the multilingual model specifically as called out here. I'll create a new profile using the multilingual E5 model that uses the in-database Onyx runtime. Here, no calls to an external AI model are needed. Of course, we could just alternatively use a transformer from a separate AI provider, just like we do for the LLM. Now I'll create a vector index using this in-database multilingual transformer. Now create the vector index status view so we can check the status of the vector index creation. Let's wait for it to complete. Let's ask the question, what are the benefits of participating in our user groups? And here's the RAG response, including the sources from our object store and the offsets. Now let's see what happens if I ask the same question in different languages. Here, we're asking about our user group benefits in Italian, Spanish, and Brazilian Portuguese. The multilingual embedding model can understand questions in all these languages and retrieve relevant content from our English blog corpus. In addition, the LLM's responses are in the same language as the user's prompt. For international communities like the R Consortium, this makes such content more accessible when using generative AI. And all of this is accessible through the R helper functions that wrap the LaMonica PL/SQL package. The code we've used today is available for you to explore further in our GitHub repository. The results of our query display in the browser: Italian, Spanish, and Brazilian Portuguese.
Thanks for that demo, Sherry. So we've seen the wrapper functions. What do they look like behind the scenes? Well, before Sherry walks you through a few specific examples, let's take a quick look at the raw PL/SQL for creating an AI profile. We use a standard PL/SQL begin and end block and call the DBMS Cloud AI procedure create profile. The profile's attributes are provided as a JSON string. For our R wrapper, we use the R Oracle package for database connectivity in R. Here, we construct the PL/SQL command as a string and then pass it to R Oracle's DB execute function for execution. Sherry, please walk us through a few examples of the R wrapper code in RStudio.
Thank you, Mark. Mark already showed the code for creating an AI profile, so let's look at dropping and creating the vector index. Here, we can see the PL/SQL block invoking the drop vector index procedure. We're passing in the select AI object name and whether the underlying database index should also be dropped. Now let's look at creating the vector index. The create vector index procedure handles the JSON attribute construction, escaping, and dynamic SQL generation. After establishing the connection, we pass in many of the parameters we discussed earlier, plus a few others that give you more control over the chunking and indexing, like chunk overlap and chunk size. Moving to the RAG function, this wraps the DBMS Cloud AI generate procedure. The main parameters are the profile, prompt, and conversation ID. Notice the generate string is being produced as part of a SQL query and then invoked using our Oracle's dbget query. And that's the key idea here. These wrapper functions make the select AI capabilities more accessible when working with R. Back to you, Mark.
Thanks, Sherry. Now, as promised, I'd like to highlight some of the broader capabilities available with Select AI. While RAG is a key feature, Select AI also supports natural language to SQL generation in various forms, from SQL query generation and execution to explanation and narration against your specific database schema. As demonstrated earlier, you can use Select AI for direct interaction with LLMs. Simply provide your prompt, whether simple or complex, to perform a range of tasks, such as generating custom emails or code, running sentiment analysis, summarizing text, and more. Select AI also offers synthetic data generation, allowing you to use LLMs to create data that matches the structure of your database tables. This is particularly valuable for testing and debugging applications when real data is unavailable when starting a new project. In addition, a capability released last month enables the creation of in-database AI agents. And this feature allows you to build interactive and autonomous agents that can perform tasks and use tools all managed directly within your autonomous AI database. If you'd like to learn more, here are some helpful resources. The R sample code demonstrated by Sherry is available in our GitHub repository. You can explore these features by creating a free autonomous AI database instance either using Oracle LiveLabs, as listed here, or by signing up for an always free autonomous AI database instance. For details, see the Oracle Cloud free tier page. So to wrap up, today we introduced the concept of retrieval augmented generation. We demonstrated how autonomous AI database with Select AI automates RAG using R Consortium documents as trusted sources to enhance LLM responses with current and relevant information. We also showed how you can develop a simple R wrapper to call Select AI functionality directly from R. So thanks for joining us.
Well, thank you for that great talk from Mark Hornick, Senior Director of Oracle Machine Learning, and Sherry LaMonica, Consulting MTS, also at Oracle Machine Learning. I'm Lou Bajik, the moderator for this session. So thank you again, Mark and Sherry, for a great talk. And if anyone has questions, please drop them in the chat, or better yet, put them in the Q&A. Looks like we've got one question there already.
Okay. Well, thanks, Lou. It's great to be here. And thanks, everyone, for joining our session. So I see one of the questions here is, do you have any issues with bad chunking? I haven't run into this problem myself, but I've been worried about retrieving bad info, which makes the output worse. Well, there are a lot of different chunking strategies. And in many cases, retrieval augmented generation with just the sliding window approach can be quite reasonable. But there are others that can take advantage of graph relationships between the various chunks. And so there are a number of things that can be done to improve that. You also have control over how large the chunk size is and what the overlap is in Select AI today. That gives you, a little bit more control over that as well. So there's just a couple of things that can happen. I think it's important really to look at what type of results you're getting. And if you tweak some of these parameters, if it will address any of the results that you're seeing, whether they're excellent or less than excellent.
Thank you.
I saw one question earlier about the foundation model that's using. Sherry, do you want to take that as far as the models that were being used in the demo?
In the profile that I created, I was using the AI provider as the OCI generative AI, and I was using the default model, which is the a MetaLlama, I think it's the 3370B instruct. But you can choose any AI provider from the ones that we support. And the LLM, we have like Azure, OpenAI, we have OpenAI or other OpenAI compatible models, Cohere, Google, Anthropic, Hugging Face, I think AWS. Did I miss any, Mark?
That looks pretty good. Amazon Bedrock we have there, as you said, any of the OpenAI compatible providers. But you can also have a private endpoint that you host your own model, because a lot of users are very concerned about using a third party for their models. They want complete control over that, and so you also have the option to take advantage of that. But also perhaps the the transformer itself. The transformer can be from a separate, say, VM or provider, but you can also, as Sherry showed in the demo, have the transformer loaded into the database itself, and so that saves you some round trip to an external system.
While we're waiting for another question to come in, so Mark, Sherry, anything you want to comment about where you're taking Select AI next? Anything you're excited about working on in the near future?
Well, we've released a whole bunch of new capabilities on the NL to SQL front. Natural language to SQL generation is really a powerful capability where instead of having to write your own SQL queries to answer questions against your database or go to IT or your DBA, use natural language and to do that. And so this ability to provide feedback to the LLM, or actually to Select AI, to then augment your prompt so that the LLM can produce better SQL Well, that certainly is one, and that's one that was released at our AI World last month. A couple of other things, though, on the horizon on the RAG front is to allow us to work with other types of transformers, including images and audio. So I think that'll be a really important direction to head and to include a lot more different types of data that we can work with.
Excellent. Sherry, anything you want to add from your side?
We have the Select AI agent as well. So you can build interactive and autonomous agents inside the autonomous AI database. And we should have a live lab for that coming soon as well. For people to just log in and everything's there. You can reserve a session and try it out live.
Very cool. Well, looks like we don't have any more questions coming in. So any final thoughts you want to share before we wrap up?
I would encourage you to give it a try and to check out the wrapper code there. That really, it's not only for leveraging the RAG functionality and the Select AI functionality, but any of the database packages that you may want to leverage can easily be accessed from R. And you may have seen some of our other sessions for the R Consortium, where there's an Oracle Machine Learning for R package that is something that is provided by Oracle that allows you to work with in-database machine learning from the convenience of R and take advantage of the scalability that's available there. So those are a few resources that will also be clickable in the slide deck that will be made available later.
Awesome. Well, thank you again both for a great talk. Thank you for everyone attending. We've got about a 20-minute break before the workshop starts at 20 minutes after the hour. So encourage you to stretch, get some coffee, and then come back for that workshop.
Thanks, Lou.
Thanks, Lou.